New materials can be used in as many ways as plastics. For example, plastics can be pressed or molded into almost any shape on hydraulic presses. They can be forced through dies of extrusion machines to form rods, tubes, or other shapes. And sheets of wood or fabric impregnated with plastic can be pressed together under heat and thus be laminated to form solid sheets, rods, and tubes. They are used as an ingredient in many paints and varnishes and can be fabricated into finished products by any of the conventional machining methods. In molding plastics, the molding method and type of press used depend upon the shape of the piece to be molded and the kind of plastic material used. For simple shapes which are molded from thermosetting material, like this plastic case, the compression molding method is used. A multiple cavity mold which has been constructed to exact dimensions out of the finest die steel is used to mold the parts. One half of the mold consists of the cavities which form the outside of the pieces to be molded. The other half conforms to the inside shapes of the pieces to be molded. In this case, 8 pieces can be molded at once. Heat and pressure are required in the molding process. The molds are heated by steam. In this case, the steam pipes run through the metal plates next to the 2 mold halves, and the mold is heated by conduction. A hydraulic pumping system connected to the press provides the high pressures needed. The mold is always cleaned thoroughly before each molding cycle to remove leftover materials or any dirt particles that may have gotten into it. The mold may also be lubricated to make certain the pieces won't stick. In molding pieces by the compression method, the plastic material is very often used in powder form. The powder varies according to the properties that will be required for the finished pieces. An exact amount, known as the charge, must be weighed out for each piece. In some cases, before being used in molding, the powder is placed into a preforming machine, which presses it into pellets or preforms of an exact size and weight. This makes it easier to determine the amount of material to be used. An operator simply counts out the predetermined number of preforms that make an exact charge, and no lengthy weighing process is required. When preforms are used, they usually have to be preheated before being placed in the mold. The preheating method shown here is the infrared lamp. Preheating prepares the preforms so they can be softened more easily during the molding process. The molding material, whether preforms or powder, is loaded directly into the heated steel cavities of the mold. The powder is spread out uniformly in the cavities. Then the pressure is applied and the ram closes, forcing the bottom half of the mold up against the stationary top half until the mold is closed. Inside the mold, the material softens under heat and pressure, flows into the shape of the mold, and fuses and hardens permanently. Then the pressure is released and the press is opened. The hard, rigid pieces are now removed from the mold, ready for use, except for some minor touching up of the parting line where the mold closed. The pieces are then placed on fixtures which hold them in shape until they are completely cooled. When the pieces have cooled, they are inspected. The flash or overflow plastic is removed, and the pieces are packed for finishing or shipment. Molding parts such as this terminal block insulator presents additional problems because it involves metal inserts and difficult flow conditions and must be molded to extremely accurate dimensions. To overcome these difficulties, a different molding method is used. In this system, the material goes first into a chamber where it is softened by heat and pressure. Then it is transferred in plastic state through a connecting sprue or runner into the mold cavity. This is called transfer molding. The inserts are placed in position on their pins. Then the molding material, in this case preforms, is taken from the preheater and placed in the chamber. The press is then closed and the bottom half of the mold moves up against the top half. As the press is closed farther, the mold and the transfer chamber move up to the plunger, compressing the molding material. Pressure and heat soften the material in the chamber, and it flows in softened form into the mold and does not distort the inserts or break delicate mold sections under the molding pressure. The pieces then fuse and harden permanently. When the curing time is up, the press is opened. Knockout pins eject the pieces from the mold. The flash is then removed and the pieces are packed. Pieces such as this switch box, which involves undercuts, can also be molded with the aid of a special type mold with removable parts. When the press is opened, side wedges in the mold are pushed out by knockout pins, at the same time ejecting the piece so that it can be removed. Intricate shapes can also be molded by compression or transfer. This relay cover is a good example. It requires complete disassembling of the mold before the piece can be removed. A hand mold is generally used to mold such a part. A hand mold is also used for small runs. The entire mold comes out of the press after each cycle. The disassembling and assembling is done on a steam table to keep the mold hot for the next cycle. An arbor press is used in the disassembling procedure. Finally, the piece can be tapped out of the mold cavity. In molding thermoplastic materials, such as the parts for this model airplane, injection molding is used. This method is very similar to transfer molding, but it is automatic and continuous. A multiple cavity mold is used so that all the plane parts can be molded at one time. In this case, the mold is lined up horizontally on the press. The heat to soften the molding material in the heating cylinder is provided by electricity, and the temperature is controlled from this panel. there are three controls because the heat is different at various parts of the heating cylinder. Highest at the point where the material first enters and lowest at the point where it goes into the mold. Water is circulated through the mold to keep it at a lower temperature than the cylinder in order to set and harden the material by cooling. The feed control is adjusted to feed the right amount of material for each cycle. The automatic timing mechanisms are then adjusted for clamping the mold halves together and for forcing the material into the mold once it is closed. Finally, the pressure control must be adjusted. On a great many injection molding jobs, the material is pre-dried in an oven before it is used in molding. The material is placed in the hopper of the injection press. The guard is then closed, which automatically closes the mold. The material drops from the hopper into the plunger cylinder. The plunger then moves forward, pushing the material into the heating cylinder. With each cycle, more material is pushed into the heating cylinder, where it is kept spread out thin by a spreader or torpedo. By the time the material reaches the nozzle, it is softened to a plastic state. Then, when the plunger moves forward again, this softened material is forced through the sprue bushing into the closed mold. Here the piece hardens by cooling. When the required cooling time has elapsed, the mold opens automatically, and the pieces are ejected by the knockout pins. The gates and sprues are then broken off and saved for use again in molding, and the parts are sorted for assembling. Some plastic products, such as this tubing, can be most economically produced by making them in continuous cross sections. This process is known as extrusion and is used mostly for thermoplastic materials, though sometimes thermosetting materials are also made in this way. The material is placed in a hopper, from which it is fed into the extruding machine. A continuous screw forces the material into the heating chamber. Heat and pressure soften the material, and it is forced out through the die opening in hot plastic form. The strip takes the form of the die, and being thermoplastic, hardens by cooling after it leaves the die. Many different shapes or cross-sections can be produced by the extrusion method. Some products, such as this plastic ball bearing retainer, need the toughness and wear resistance which results by combining the qualities of paper or fabric and plastic. For these products, a process known as lamination is used. Rolls of paper or fabric are used in combination with thermosetting resin in liquid form. As the paper goes through, it becomes impregnated with the thermosetting plastic. The impregnated paper then passes into a heated dry house, where the resin is dried, but not cured. Then, after it is dried, the impregnated paper is rolled up again. To make the laminated material in sheet form, the paper is first cut to size. The sheets are then weighed and stacked, each stack being of an exact weight calculated to give the precise thickness required in the finished sheet. Each stack or book is then placed between two metal plates. Any type of finish desired can be obtained because the finished sheets duplicate the surface of the steel plates. The stacks or books of impregnated paper, each between two steel plates, are placed between the platens of a hydraulic press. The press is now closed. The heat is then turned on so that heat and pressure are exerted on the impregnated sheets, laminating them. This is the point where the curing of the material takes place. After the sheets have been under heat and pressure for the required period, which in this case is 2 hours, the heat is turned off. Cold water is then sent circulating to the platens. When the material has reached room temperature so that there is no danger of warping, the press is opened and the laminated sheets are removed. The result is a hard, tough, rigid sheet with a fine surface finish. From the impregnated rolls, tubes can also be made by sending them through a tube winding machine. Fine weave fabric that has been impregnated with resin is used for this. The rollers exert heat and pressure, and the impregnated material is wound onto a steel mandrel of the required diameter for producing the inside diameter of the tube. The wall thickness of the tube is checked often to make certain it will be the required dimension. When the required thickness is reached, the tubing still on the mandrel is removed. And placed in a dry house. After the tubing has cured, the steel mandrel is pulled off. The tube is then finished to exact dimension by a grinding operation. Laminated material is also provided in rod forms. Tube stock is used to make a product such as a ball bearing retainer. The conventional machining methods are used, beginning with sawing off the required tube length on a circular saw. The next step is turning the outside diameter to exact dimensions on a high-speed production lathe. In this case, 5 pieces are machined at one time. A very sharp cutting tool is used at a rapid rate of feed. The inside diameter is then bored. The final machining operation is milling the 8 pockets that are to hold the balls of the completed ball bearing. Here, 2 high-speed and rapid feed are used. Standard machining procedure is used and comparable tolerances to metal can be obtained. The finished retainer, which can then be assembled for service, is light in weight, tough, and wear-resistant. Not only laminated materials, but all plastics can be machined. Thermosetting materials, because they are so heat-resistant, can be sawed, milled, or turned much the same as soft metal. Much higher speeds and larger feeds are possible than for most metals. With thermoplastics, coolants are sometimes required to keep the material from softening under the heat generated. Many plastic pieces that are made by molding must undergo several finishing operations before they are ready for service. On this telephone handset, for example, the gate must be cut off and smoothed out to the contour of the piece. The threaded metal inserts retapped to clear off all plastic material, all overflow plastic or flash filed and sanded off, and the curved contour of the piece maintained. The parting line buffed off, and the entire piece polished to a glossy finish. First, the gate is cut off with a bandsaw, using a blade suitable for cutting plastics. A drum sander is used to remove some of the flash, care being taken to maintain the contours of the piece. A drill press with a tapping attachment is used to retap all the threaded metal inserts. Additional flash is then filed, sanded, and scraped off by hand. The next operation is buffing the entire piece on a buffing wheel, using moist, greaseless abrasive compound. This buffing operation removes any slight remaining flash and smooths off all rough spots. Finally, the piece is polished and wiped on softer wheels to bring out its luster. Small pieces that are not easily breakable are often finished in batches by a process known as tumbling. For flash removal, steel shot is placed in a wire tumbling barrel. The molded pieces are then put in. The barrel is turned at a predetermined speed, in this case 65 revolutions per minute. The rotating motion of the barrel rubs the pieces against one another and against the metal shot, gradually removing the flash. With the flash removed, the pieces are ready for the polishing process. For polishing, usually smooth wooden and plastic balls are placed into the tumbling barrel with the plastic pieces. Polished or waxed wooden pegs are also added. The barrel is then rotated as before. They are now finished to a high luster and ready for use. Thus, out of the plastic materials supplied in the form of sheets, rods, and tubes, liquids, and powders, are manufactured a variety of plastic products ranging from simple articles for household use to highly engineered essentials to the operation of transportation, communication, and industry. And their number and variety is constantly increasing.